Now we got all of you. Great. So just announce this is June 2019 common paper. June 2019 common paper.
This is the June 2019 common paper.
Okay, so do you want to explain how you're going to do maybe first, or do it, or call on them to question them, whatever way you want to.
I'm not going to write 2.1.1 down, but I can say what it is.
Okay, I'll tell you what, you talk and I'll just draw. Okay. So you carry on talking. Just read 2.1 and then go into the question so that the person like Mr. Detour can know what's going on.
Block A with a weight of 19.6 newtons is at rest on a rough horizontal surface. The block is connected with a light inelastic string that is running over a frictionless pulley to block B of mass x kilograms. Block A now accelerates at 4 meters per second to the power minus 2 to the left. The coefficient of kinetic friction between block A and the surface is 0.2.
So the coefficient of friction will come on. Okay.
2.1.1. State Newton's second law of motion in words. Newton's second law of motion. When a net force acts on an object, it produces an acceleration in the direction of the net force.
That's right. And then just add on. The acceleration is directly proportional to the net force and inversely proportional to the mass. All of that. Okay.
2.1.2. Draw a fully labeled three-body diagram of all the forces acting on block A.
So thanks so much, Matthew, for volunteering on the spot. Putting you this on the spot.
Block A. So here is weight for the force of gravity. And here is the normal force. And here we have tension from the string. Friction.
Super. Okay, where would you maybe lose a mark? Not the length, but the direction of the arrow. Just correct the direction if you don't mind, Matthew.
Which direction?
Yeah, it must be straight to the right. To the left. It doesn't have to be straight. What I mean is it mustn't be curving upwards. What make it horizontal? That'll run out. Then I'm going to have to stand the board, I think. We'll get it dusted. Okay, so you may have lost a mark if you didn't look horizontal. Okay, so there we go. So that's the force of tension. Super. Any other points anyone wants to add? Good point. Matthew, the subject advisor is good. Yeah, you know, it's never been necessary up till this year, but at the meeting at the beginning of the year, the subject advisor said he wants a key. Good point, I completely forgot about. Why don't you just put a key, what all those mean? exam, it's going to take you 1 minute to write. And now the poor marker doesn't have to struggle. Okay, who could fault that? That's perfect. Now we're not left guessing. And you know, everybody's got their own little symbols and letters of the alphabet, so how's the poor examiner going to know? Some people use W, some people use forces, G, you know, F, G, F, W. At least this way the examiner is going to give you your mark. Great. And that's only worth 2, no, that's worth 4 marks. Okay, 213, calculate the magnitude of the kinetic frictional force on A. Okay. So we start with the formula. Right. Look at that, he puts a new kinetic. Not just new kinetic out of the in that sheet. Got it? I always forget that.
So this is normal force.
And that's the normal force.
I don't think they give us an assignment to calculate.
But they give you the weight.
Yeah, so we can just.
Yeah. They already give you it in newtons. They already say the block has a weight of 19.6 newtons.
I'm good. Wow! This is liberating.
Look at how black, green.
And talk and chalk.
Yeah.
Oh my word. You know, I remember my daddy, his suits. But that was a principle, but he always, and my dad's suits, because when you write, so will tell you in the older name, we always board, and now we stand far away, but we used to stand against the board. So you write and you talk and you chalk, right? You talk and chalk.
Yeah.
And those days we could turn our backs to the learners and they listen. But anyway, so we talk, and I used to wear mini dresses. But that was in those days, it was the 80s.
That's 70s.
Yeah, so you know, and those boys listen proud because when I stretch like that to start the board there, you know what I mean? Like, the boys were listening to us. Yes, and then you think like, and then you want to pull your dress a little bit like this. But then after a while you forget. But anyway, and then my dad's suit, year and year, was permanently full of that, the dust, the chalk dust. Used to come down and it was on his shoulders.
Like that.
My mommy always, like dandruff. I'm just popping in. Could I just ask you something?
Sure.
This is really intense stuff that you are doing here, sir. Do you know that they've just released a video? Moscow has just released a video with a bomb that the biggest nuclear bomb. Yeah, no, it was called. What was it called?
Tsar Bomber.
Yes.
The Tsar Bomber.
Tsar Bomber.
Oh.
The mother of all bombs.
That's the mother of all
Isn't it? That's right. Okay, mother of all bombs. So this bomb, nobody ever even seen this material or as nucleus really this day. And they've just released it to show what they have designed in the 60s, eh?
Oh, right.
Yeah, it is, and I think it was 150 tons. They said they actually exploded the bomb in the Arctic Circle.
Oh.
Isn't that
I saw that. I thought it was a nuclear bomb. I saw that on the news.
Yes, and it was, they done it in the 60s to test this bomb.
Yeah.
It was 55 million times stronger than the bomb that fell on Hiroshima.
Wow.
So it's no wonder the poor Americans were shaking in the boots, eh? Yes, like that. Anyway, the only bomb that's going to go off is that we're going to get a 100% pass rate. Yes, yes, sir. That's the bomb that's going to go off. That's the mother of all bombs.
Calculating physics.
I just want to say, do you have time for school, eh? With all your passengers, so they are all going out of school. Yes. Can you excuse them for 1 second?
This is the formula for the this is the yeah, you basically plug it in and you get 3,92 meters to the right. Why is that? Because friction is resisting.
Okay, so
what did you say, sir?
So we worked out the magnetic friction.
I just move on to the way, so can the camera get you? Can the camera get you? No.
So 3.92 is it? Camera?
Is that right?
Yes.
Looks. A flip of 19 looks like 3. Okay, you still got plenty more to work on either side, so carry on.
Oh, it's can I erase this?
No, just work on to the right of it, in that end of the Okay, so we've worked out the magnetic friction for warm up. Now for 6. Calculate the weight of B, or block. The mass of block. Okay, go for it. 214. 214. Now here's where the rubber meets the road. Here's the tough part. Force net equals mass times acceleration. Love it? Force net is mass times acceleration, right? That's the force of tension plus the force of weight of B equals the mass of B times the acceleration of B.
So I have to make this minus the mass. So I have to make the mass a negative or can it stay positive?
The mass always will stay positive.
Oh, and down is negative, so we can say minus. It's minus. For the acceleration.
Oh, we get that 11,92 from.
Actually, that's because I want this from you while you
Okay, so won't you here on the left work, you've got to work out the tension first. So how are you going to work out the tension?
The net force acting on it.
On A. You've got to do it for A because you've got to work out the one you know the most about. So A has only got two forces acting on it, tension, you already know friction, you know acceleration, and so you've got to just work out the tension on A using Newton 2. Force net.
Can I just say tension?
Sorry?
Can I say tension instead of
You can also just say force net equals that's 31st is force kinetic plus there's two forces acting on A and tension. Great. And what if you put force net A, subscript A? Okay. Great. Now, what are you going to do next? And that is equal to?
I don't have to do this one.
Okay, so you're going to use Newton 2. You're going to say force net equals MA. That's MA equals root. That's it. And guys, what when you see a problem like this, what's the first thing you're going to do in your mind? You're going to go, okay, choose the direction. First of all, in your mind, do this. Don't do it in the exam. And then which direction is going to be positive? The direction is left is positive. Okay, so your tension will have to be, that to be positive, and then your kinetic friction will be negative. Friction is always, by the way, must be negative.
So, must I make right negative?
Make right negative and left positive. Lovely. So you know the mass of it. Did you show that you worked out the mass? You put weight equals so you worked out weight was equal to MA or MG. So M was equal to 90,8 divided by 9,8, that gets 2, right? So your mass is 2 times your acceleration. Now, that's the thing. That 4, that's 2 times 4, right, guys? Be careful with your dots. I don't know, are you allowed with your dots like that? Okay, fine. I take it you're allowed to use dots as long as the examiner not thinking it's 2.4. And just check your directions. Your mass is no direction, your A is the correct, that's positive. Your kinetic, just check that it's negative. And in that sum, is it negative? Look, you've got 8 equals 3.92, but that should be minus 3.92.
Yeah.
But look, to your left, you've left it positive plus 2. I'll show you. here is where it needs to be negative. And then it becomes that. So T is 11.92. Great. So let's see, your final thing, force next, is mass times acceleration, 8 equals force kinetic plus, you're working out the tension. So tension is 8 plus that there. So there's your tension. So now you're going back to there. Okay. So now for B, is the tension negative or positive? For A, it's to the left. But for B, it's equal and opposite moving through, right? So, you see what I'm saying, guys? Make sure that when you do it there, that your tension is pulling upwards, which is negative. There's the only place you're going to get really stuck. This tension must be upwards, which is negative. Okay, tension plus MB times 9.8 equals. Guys, please, just knock it off. Thank you. Don't talk. Just follow. Otherwise, I'm going to have to move asthma this time. Okay, it's the mass of B, which we're trying to find out. We don't know the mass of B, times the acceleration. Okay.
Acceleration is 4, right?
Yeah, acceleration is 4. So you should say MB times 4. Is everyone following?
Yes.
So,
thank you.
and what is the weight of B? It's the weight of B times
Mass.
it's the mass of B times 9.8, right? So that's got to go on the left, in that space where you wrote it out. Yeah. No, that's right, but here. So there's going to be 2 MB, but it's going to be MB times 9.8. There we go. Equals 4 MB. That's it. All is correct. So 5.8 MB is 11.92. So MB is 11.92 divided by 5. So what did it come to? 2.1 kilograms. Everyone get that? Yes. Who got that? Just hands up how many X each got 2 people go. Well, who got most of the way, but just maybe got a sign wrong? Most of the way. Most of the way? Well, Tamika, well done. And those who get close, please go over it. Now, I'm not being critical, but I put Matthew on the spot. Could have set it out more neatly. His blackboard technique is almost as bad as mine. Okay, so in the exam, please do the exam a favor. Don't put stuff everywhere. It must follow straight down underneath itself. And if you're going to work out something first that you need for something later, just work it out separately. Tell the examiner what you're going to do. Don't leave the poor guy guessing. Because I'm never marked. Well, I can tell you something. I have marked. And if I get teased off by somebody laying something out more difficultly, I'm going to mark him. I'm going to in a mood to mark him down. And you don't want to get the examiner in a mood to mark him down. Okay, take that down, anybody hasn't got it? And then who's going to do number 11?
I was not going to do 2.2.
You were going to do one. Oh, there's still 2.2. I'll tell you what, don't rub anything
That's
off.
MB. That's a acceleration of the
Any questions of Matthew? Any questions? Okay, let's do 2.2. I'll rub that off. Yeah, I've got to rub it off. It's a little bit hard to get off, so we're going to squirt it off. I'm going to rub it off, yeah. Better take that out of the way and everything, otherwise it's going to get wet. I think I'm going to have to sand this board and rub it. It's a little hard to get off, but it's perhaps a little easier with water. It will wear smooth with time. But it's still great. I love having this board. I don't mind having to do a little bit of this. Interesting to hear Miss Jacobson fessed up that she wore, I better be careful what I say, mini skirts and those. We were brought back dear memories of the 70s and 80s. We had a Latin teacher, Miss Cooper, and I hated Latin, but she always wore a miniskirt. When she sat like this on her head, we all look forward to Latin. Okay, so you want me to draw? Or you good to go? Okay.
Wait, am I supposed to draw 2.2?
I think for the video. Can they see the left of the board? Okay. So maybe you could just draw briefly.
Is that a longer piece of chalk?
Yeah. The yellow is harder to get off, but whichever color you want.
Thank you, Matthew.
That's fine. So nice seeing you guys actually doing the work. Okay, so this is Halley's Comet. It comes around periodically every X number of years. So here last in 19, sorry? What is that saying? Okay, 1986 and 2016. 86, so that's 14 and 16, that seems to be every about 50 years.
You can see that says Earth, right?
There is Earth, okay. I have a vague recollection of seeing Halley's Comet.
So you also have the name of Halley's Comet?
Is that 1966? 86. Okay. Because I remember us going into our backyard, taking a pair of binoculars, knocking a stake into the ground, tying the binoculars to the stake, see it in the sky, and we didn't want to shake it when we looked through it. I remember that. But whether it was Hades or another continent. This all right? Okay. So for 1 mark, yeah.
2.2.1. Is the magnitude of the force exerted by the comet on the Earth the same, greater than, or less than the force exerted by the Earth on the comet? Answer is the same.
Why?
Because gravity is. I can't remember how to explain this, but I
Did
know.
everyone get the answer the same?
Yeah.
And what are you going to do?
Explain it.
Newton 3.
You're going to say
Newton 3.
Newton 3. For every action, Earth pulling on Halley, there is an equal and opposite reaction, Halley pulls on Earth. That's your full explanation. Newton 3. Okay. State whether the acceleration of the comet is largest position in 1988 or 2016.
Answer is 1986.
Okay, 1986, why?
Because when the comet gets closer, the force between them gets stronger. So, and when the force gets stronger, the acceleration also increases. So when it gets here, acceleration will be the strongest.
So what force is that? Can you give me a formula for that force that it experiences?
Gravity.
Just write the formula. It's on your BFF. It's the force of, and it's equal to,
Capital G or small?
whichever you like.
Small D.
But it's also equal to, what is that formula? Newton's universal gravitational constant formula? G M1 M2 over R squared. And because the R, or distance from the sun, is so small, the force is so great. So I would say all that. And then what of other of Newton's laws do you have to quote here? what's the law that links force and acceleration? Force and acceleration. Newton. 2. The greater the force, the greater the acceleration. So, all of that's got to be in your explanation. Who's got that correct? Everyone, who got
I just said the comet crashes in the earth because of the force being stronger.
Okay. Who got that it was stronger in 1988? Everyone. What did you guys give for your explanation?
I said that in 1986 the comet is closer to the force stronger than
Closer to the. What is accelerating this comet? Is it the Earth or the Sun? What is accelerating this comet? Does it revolve around the Earth or does it revolve around the Sun? So it's the Sun that's accelerating. So you're going to explain that because this is the way comets move. Out there, almost nothing. So they move slowly. As they get closer to the sun, they go faster and faster. So then they get so fast, they whip around the sun, and then they get slower and slower. Whip around. As opposed to the Earth, which just keeps the same, more or less, speed around the sun. Okay. So it's the sun that is accelerating the comet. So your mass 1 is the sun, your mass 2 is the comet. Earth plays no role in the acceleration. Okay, then 2, 2, 3. Calculate the magnitude of the force exerted by the Earth on Halley's comet at its point of closest approach. This question just goes on forever. So what formula have you got? Yes, that's the correct formula. In that data sheet, I don't think they give the name of the force, do they? I don't know about data sheet, but there's no force, it just says F, doesn't it? It doesn't say G or anything. Do they say F, G? With that formula, don't they say any force? They just say F. So do not say FG, because that's you quote the formula only in your data sheet. Remember that, everybody? Not your own formula. Formula in the data sheet first. And if they say big M, small m, M1, M2, put it exactly like it is. So where did you get your mass of the Earth from? You got it from your data sheet. Okay, you can't do this if you didn't know it's on your data sheet. You'll be stuck. sure before you write your matric exam, you go through every constant, every formula on your data sheet, and you know how to use it. Please do that. Work an hour.
What is the kilometers?
Oh, so mass is in kilograms. Yeah, it's in kilometers. So you've got to convert it to meters, right?
So divided by 1,000.
Kilometers to meters, you. 1 kilometer is how many meters?
1,000.
What did you do to get that?
You divide by 1,000.
You didn't divide by 1,000.
Times about 1,009.
Yeah.
You convert from meters to kilometers.
No, it's in kilometers must be.
But in kilometers, you got to turn it into meters.
But got the radius of the earth, I must not convert this into kilometers.
Do they say that is from the surface of the earth?
When you add the radius of the earth, when you do this calculation.
You're a genius. Yeah, you've got to add the radius of the earth to that. Who's got the radius of the earth? Is that on the data sheet?
It is on the data sheet.
Oh, okay, so you've got to add the radius. And what's the radius of the earth in kilometers? In meters. Okay, so convert your distance of the comet to multiply times 10 to the 11, right? To get it to meters. 1.3 times 10 to the 11.
So we leave it in meters.
You must put it in meters. Or say times 1,000 to show the examiner what you did. And who would have thought of adding the radius of the earth? Fantastic. You're the only one. You got it right. I would have got it wrong. I would have forgotten that. Science is precise.
And must I work this out step by step, or can I just do this whole thing?
I can just give an answer. Let's see if everybody gets the same answer. Isn't it good that we went over that? We've learned something. Always make sure you go from radius to radius. Now, why don't we go from the radius of the Hades comet? Because the radius is like, doesn't matter, it's about a kilometer big. So, it makes no difference. It's a small little thing. Do you guys know what happens to comets when they come close to the sun? Do you know what they look like here? They just look like a big, dirty snowball. Okay, so they look round like a big snowball that you roll in sand. But as they come closer to the sun, they melt. And the tail of the comet always faces away from the sun because the sun's solar winds blow the gases of the comet outwards. So as it comes here, the tail sits outwards like this. Now, why doesn't the tail sit behind it in the direction it's moving? Because it would do that if there was friction in space, right? Like your hair blows back because of friction. There's no friction in space. So the only thing that blows it is these like solar winds. And then when it goes back, it starts to shrink again into a snowball. It gets smaller and smaller. And then it's back to a snowball. And that's why when you see a comet, it looks like that. But it always points away from the sun. People of old days were very superstitious that when they saw a comet, they thought the world was going to end. And you know that if a comet hit the Earth, it would end the world. So they've got good reason to fear. Anyone get that same answer?
Yeah.
Okay, Matthew, you're a star. Thank you so much. Would you like that, everybody? Okay, let's get someone to do to get 3 because I think Ezra you prepared 4, right? Okay, so let me just clean this and then Ezra can come and do 4. I'll just leave that on as I can come to the fold.
Question 4 says, a ball with a mass of 0.2 kilograms is dropped to a height of 0.8 meters onto a hard ball. It bounces straight up to a maximum height of 0.6 meters. The floor exerts a force of 50 newtons on the ball. Ignore all effects of nature. 4.1 states define a projectile. A projectile refers to an object which either dropped from a position above Earth or launched vertically into the air. The only forces acting on the object would be gravity.
Okay, so if an object in the air with only one force acting on it, you've got more than one. The main point is one force of gravity acting on it. Great.
Point 2 says write down the magnitude and direction of the force that the ball exerts on the floor. It's 50 newtons because the magnitude that the ball exerts on the floor is the same as the fluid in the ball, which is 50 newtons, and it's downwards because it's in the opposite direction.
Okay, so to prove your point, you're going to quote.
Newton 3.
Newton 3. The floor on the ball is the same as the ball on the equal and opposite.
Okay.
And you mentioned if down is positive, the force upwards is negative. Got that, everybody? Yes.
4.3.1 calculate the velocity at which the ball strikes the floor.
Okay, great technique. Write the variables first. Great technique. Good for example. Make sure you're using a delta y, not a delta x. You can tell me why. Y is vertical, x is horizontal. Great. And we try to find
Your initial velocity will be 0 because the ball is being dropped, so it doesn't start with any velocity. Acceleration is 9.8, and I made it positive because I took downwards as positive.
Okay. So why did you write that with your variable down positive?
This is like a downward.
Yeah, just write it with your variables. Okay, so your examiner is happy, he knows exactly what to do.
Delta y is 0.8 is given, and final velocity is unknown. We have to calculate. So the formula is
anyone get a negative 9,8? Does anyone work with a negative 9,8? Because that's the only place you're going to go wrong. But she's chosen down positive, so she's working with a negative, with a positive 9,8. Super, who got that? Just hands up. Just hands up high again. Let's see how about off the clock. Now the rest of you, why didn't you get that? Did you do it? Alicia, did you do it? Did you do it at all? Kirsten, did you do it? But you didn't get that on. You know where you went wrong? Did you use that formula usefully?
No, it's not.
And you added your 8 to
She added the two whites together.
Oh. Oh.
After the bouncing as well.
Okay. So you're just working from the site to here. To 0. Okay. So, Janet, where did you go wrong?
God damn.
Oh, you used 0.6.
Didn't calculate the one for the bounce.
Because they only want the velocity at which the ball strikes the floor.
Exactly.
It doesn't strike the floor after it bounces.
Now, let's see how you're going to do the next question. It's quite difficult. Okay, let's see how you do it.
Calculate the time that the ball is in contact with the floor. It bounces off the floor at the speed of 3,433.
Okay, ask them how they're going to calculate. I want to see how many of them know how they're going to do this. Just ask them, see if anyone's got an idea. Yeah.
I use that.
Did anyone do it?
I use the formula where time, final velocity, initial velocity, and the height.
Did you do that?
I use acceleration.
You used acceleration.
What is your answer?
0.35.
I also got 0.35.
I didn't get that.
That's right. I know you've got to use momentum.
Momentum.
Momentum. Change of momentum is force times time.
But
Give
if
you
you
the
use
force.
the V final equals V initial plus A delta T, and you substitute it, making delta T the subject, you would get 0.35.
Okay, so it bounced up with. So it bounces off the floor at that final velocity. So did you work out? Just show me how you did it. I want to see how you did it. I think I would have naturally just gone for what the change of momentum equals impulse equals force times time. I think that's what I would have done.
I don't even understand.
But I want to see if you can use equations of motion or Newton 2 to do it, because has everybody got that down on the left?
Yes.
Because then maybe I can just do it with momentum and see if we get the same answer. Okay, so now I'm going to say delta P equals V final minus V initial. AV final minus AV initial. We're given that, yeah. Change V. Final momentum minus initial momentum.
These are ideas. I don't know this.
Okay, good to see. You got it. So what is the mass? Just leaving out all the niceties. The mass is 0.2 times up is negative minus, what is its final velocity upwards? 3.43 minus initial momentum when it hit the floor. What was the speed when it hit the floor? We worked it out in the first problem. What was the velocity when it hit the floor? Minus 3.96 times 0.2 is equal to force times time, or impulse. Could somebody maybe work that out? 0.2 times minus that is equal to, force was equal to, they give it us 50. The force was up, so up is negative times delta T is equal to, what does that all come to? Let's see if it comes to your one. That's correct. So it comes to minus 0, comma
0.29 times.
0.29.
No, sir, I did with taking the force over at the same time.
Okay, but just what did this on the right come to? So this is at multiply, by the way. This is 0.2 times minus 3.3.
It's minus 1.46.
7.8. So now delta T is going to be that minus 1.478 divided by a minus 50. Minuses cancel out. You also get 3.2. Comma 0.295 seconds. Okay, now let's just see what you did and see if it's possible. Okay.
Because I saw I was
So you said V final is V initial plus A delta T. You see, here's your problem, as well. You can't use that formula. You know why? There's two accelerations involved. There's gravity and the ground pushing it up. Sure. Do you guys see why you can't use that?
yeah.
When the ball hits the ground, there's still gravity acting on it. But then there's some other acceleration upwards. That's changing the direction of the ball. You don't know that acceleration. They don't give it to you. So you don't have a clue what A is. It's not just 9.8. There's two forces involved.
That's funny side though.
You can't use anything like that. You can't use that. Let's just see if you've got another formula. Just quote your formula, write for it. He doesn't, no, just quote it. Which formula?
It's supposed that delta y is equal to, in brackets, fi plus if. Vi plus vf. Close brackets, times I.
Divided by 2.
Yes.
And that's all divided by 2.
Everything divided by 2. Yes, sir.
So that is a formula for finding displacement. That's your equation of motion.
But we have the displacement, sir.
So, what is the displacement?
0.6.
Sorry?
0.6, they give us a maximum height of the advances of 0.6.
So, if you know the 0.06, you could work out what the velocity was when it started to bounce up. You could work that out. But that,
That's the thing, bounces off the floor at the speed of 3.43, so that is the velocity as it bounces up.
yeah, I'm afraid this is the only way that it's going to work. Only way. Okay, so that's the correct answer.
What's it? I got it.
You've got to use momentum when you have a collision with something. I'll give you another example of a common problem like this. A ball comes like this, it swings down, it's got a certain velocity and it hits a block. You have to use momentum.
How does a ball swing?
On the screen.
So say its height here was 1 meter and it's 1 kilogram.
Oh, I see.
1 kilogram and it falls to a vertical height of 1 meter. Then you can work out the energy was mgh, which you convert into a half mv squared. So now you know the velocity when it hits. But you cannot use equations of motion to find out what's going to be the, say it sticks to this, what's the final velocity. Whenever something hits something like the ground, you've got to use momentum. Unless they give you more. But look, they give you force, they give you time, they give you initial momentum when it hits the ground, they give you final momentum afterwards. That's the way you do it. Okay, doke. So what else have we got?
Just a graph. That's a graph.
So we've calculated the time. Now the ball takes 0.4 seconds from the moment it just drops until it strikes the floor. Sketch the graph of position versus time. And then you've got to, for 5 marks, you've probably got to do it quite accurately. But we know all the details now. Okay, you see, if you use that formula, what would you use as your initial velocity? When it hits the ground or initially? Or did you take, which velocity, Pascal, did you use in your formula for your initial velocity? When it hit the ground or when it took off again? When it took off again? No, you see, you're not even using the velocity that I used, the final velocity, which was, the initial velocity, which was that. Even if you used that, you would get V final, let's say, that was its, sorry, that was V final, that was V. So you use that one and that one in there, divided by 2 times delta T. No, it just cannot work. I can see it won't work. It's got to use momentum. Okay, perfect. There we go. So, it started at a height they gave us of 0.8. Great. They say we use ground as naught. There we got ground as naught. It took 4.4 seconds to hit the ground. We know there was a small delay a tiny little time that it was flat with the ground. We don't even have to show it of 0.0295 seconds. That it was, the ball was squashed onto the ground, and then it took off again. And did they say how long it was in the air after that? Do we need to know?
No, it doesn't.
Okay, and then they give us the height that it bounced. Do they?
0.6.
Do they say it was 0.6 it bounced? Okay, so we've got 0.6 there. So it all looks good. Very good, right.
So I don't know how to do the last question. I got it last.
Okay. If a person is 3 meters away from... Okay, so thanks a lot, Ezra. Well done. We learned a lot, didn't we? Did you guys learn a lot? They often mix momentum with equations of motion when things are in the air, everything obeys motion. When things hit the ground or hit other obstacles, it's always momentum. Okay, 4-4. If a person is 3 meters away from the ball, strikes the ground, runs at a constant speed of 2 meters per second, sees the ball at the same instant was dropped, will he be able to catch the ball before it strikes the ground? Use a calculation applying projectile motion principles to show how you arrive at the answer. Okay, so you've got to draw it. That's the first thing I'm going to say to you. You're not going to figure out what's happening unless you draw. So this is like a cricket, a fielder is going for a ball. And he's running at a certain constant speed. Okay, so a person 3 meters away. Here's your fielder, he's going for the catch. And he's running, and he's 3 meters away from the ball. From the point the ball strikes the ground, runs at a constant speed of 2. He's going at 2 meters per second. He sees the ball, the same instant it was dropped, will he be able to catch the ball before it strikes the ground? So, is this the same ball? Is this the same ball we were talking about? So, it has to be the same ball. So, how high was the ball when it dropped? Till the time. And it just not come out? Okay, that's all we need to know. It took 0.4. Now, first of all, did you guys know we're talking about the same ball?
Yes.
Because if we aren't, I was looking for all the details regarding this ball. Sure. So we know we got 0.4, and he's got to run 3 meters at 2 meters per second. So any suggestions how we figure out, will he be able to catch this ball? Remember, the ball is falling straight down, right? And he's got 0.4 of a second to catch it.
So shouldn't we find out how long it takes him to run that 3 meters?
Let's find out how long or how far he can run in 0.4 seconds. Should we do that? So now we take this formula. Displacement is distance over is velocity times time. You're using the formula velocity equals displacement over time. So let's find out his displacement. His displacement is velocity times time. Notice I'm using delta x because he's running horizontally. Everyone understands how I got this. If you take speed times time, you get distance that you travel. These two, the time is 0.4. It's obvious that it's only going to travel 0.8 in that time. But he's got to travel 3 meters. But he's only going to be able to travel 0.8 meters. So he will not be able to catch the ball. Does that make sense, everyone?
No.
Okay, Mustafa, if I travel at 60 kilometers per hour for an hour, how far do I travel?
60 kilometers
Per hour.
for an hour.
How far do I travel?
Wow.
6 kilometers per hour for an hour? How far do I travel? I travel 60 kilometers. Now, how do you work that out? You say velocity times 1 hour. You have 60 kilometers per hour times hours. It's allowed to I'm left with kilometers. Right? Or let's put it this way. Delta x equals velocity is delta x upon delta t times delta t. Those cancel out. Velocity times time leaves you with displacement. Let's try it again. Mustafa, if I'm traveling at 60 kilometers per hour and I go for half an hour, how far do I go? 30. If I go for 2 hours? 120. It's just your velocity times time gives you your distance. Okay. So his velocity is 0.2. His time is 0.4, his distance he travels 0.8, but the distance he's got to go is 3, so he's far short of catching the ball. He's 2.2 meters short of catching the ball. Everyone happy? So we have learned quite a lot from this question. Now guys, please make sure that you can do it in the exam. That's why we're doing it beforehand, to get all the little tricky things out. Know when to use momentum. This is one of your equations of motion that are not given. Velocity is displacement upon time. Another equation of motion would be acceleration is change of velocity over change of time. It's not in the data sheet, but you've got to know it. Which is equal to final velocity minus initial velocity over change of time. It's not in your data sheet, but you must be able to use what acceleration, what velocities are. Okay. So, any questions? Who's going to do another question? Okay, let's just, for next time, divvy up this work. So Pascal's doing question 8, right? Okay, Pascal's doing question 8. Oh, so Zina's doing question 5 still. So Zina's doing 5, Pascal's doing 8. We've done 4. So who wants to give us a question that you want to do? Everyone's going to do something. Volunteer? Okay, Aidan's doing 6. Okay, more volunteers? Okay, David's doing 3. Okay, some more volunteers. We've done 4. We've done, did we do 2? And someone's got to also, a few people got to do 1. Okay, who wants to do 5? What is 5? Oh, Zina's doing 5. Oh, sorry, it's uniform part. So, who wants to do 7? It's a nice, simple electrostatic one. Who's going to do the electrostatic problem? Who's doing electrostatic work? Okay, Alicia. Thank you, Alicia. And then how many questions? My paper's been writing through. What does it go up to? 8. Just to 8. Okay, so we're missing now. Okay, 1, 2, 3. You want to do 1, 2, 3 of 1, 1.1, 1.2, 1.3. Okay, would you do 1.1, 1.2, 1.3? And would you do 4, 5, and 6? Is that right? So 4 to 6. Jared, would you do 7, 8, 9, and 10? Okay, so Alicia is here, Kurt's here. So that's all done. And then we'll probably go on to some. We're going to be going on to the 2018. I have it loaded. The paper 2. Sorry, 23. This is what I loaded for 2018. Or I'm making you June chemistry paper. Is it really breaking? 25 points, and does it end how far?
No, it ends at 25 points. The period.
The period ends at
25 points.
and the time now is
Almost 10 points.
10 points. Okay guys, what I suggest you do is, although some people are presenting it, I think you need to work on the questions we haven't done, because you've got to get up to speed. Okay, so finish working on this paper. Those questions we haven't done, make sure that you got it. I think we need to make sure that we can do these, guys. And if you've got any questions, ask. Don't just sit there and do nothing, ask.
So can we stop it?
Thank you.